It's Giovanni Sosa. Fortunately, my partner Artour couldn't make it to be with us this morning. Something came up for him last minute, so here I am. You have me completely for that 20-minute period. I'm from Crafton College. I'm the Interim Dean of Institutional Effectiveness Research and Planning, and I'm going to spend the next 20 minutes or so talking about statistics. And to be more particular, I'll be talking about statistical significance and effects. So I don't presume everyone in the room is completely fluent in all matters relating to statistics. I do, however, hope that at least there is a working familiarity with some of these more fundamental concepts, like at least p-values and statistical significance, because you see me often allude to those very topics as I proceed down my pathway here. So we'll first spend maybe 5 to 7 minutes talking about these statistical issues, and then we'll transition over to, I think, better contextualizing that discussion in terms of how things work at our college, at Crafton High School. So I'll start here. I want to start here with a hypothetical example. Let's suppose you're interested in trying to somehow impact or affect GPA at your campus or at a particular college. You may, for instance, think, well, maybe if we develop an intervention whereby we have students visit a tutoring center, receive one-on-one assistance from another individual or groups of individuals, there may be some sort of positive impact on the subsequent in-class performance. Now, you conduct a study, you look at your findings, and what you see here in that column, of course, is that p-value. You find that there's a significant association between visiting the tutoring center and the resulting GPA that you see. You come back and you think, oh, let's enhance on this, let's do something else. So rather than tutoring, let's look at something called supplemental instruction. I'm not going to assume everyone knows what that is, but supplemental instruction basically is a model. For those of you that are unfamiliar, you can think of sort of akin to like maybe a graduate assistant for a class, where you have a student that's already taken that class, already relatively well versed with the topics for a set of topics for a given class. They attend class along with the student, but they also hold their own discussion section, if you will. So the students in that class go and visit this SI leader, and that person then facilitates that discussion, reviews topic matters, etc. So let's suppose you're interested in that particular piece. You also look at the corresponding p-value here. You find that there's a significant association. Great. So we know tutoring has an impact. We know SI has an impact. What about a combined approach? So you do both. You do a third study where you look at both, and students are exposed to both the tutoring center and SI, and of course, in the end, you see that it's also statistically significant. We reject null. So all three strategies seem to work. You might be tempted at this point to think, at least exclusively on the basis of that statistical significance, that all these are equally effective. Doesn't matter which one we use because they're all statistically significant. Why don't we go with the option that's most affordable or most easy to implement? That's where you would have run astray. Because in fact, when you were to look at the actual associations between the variables in question, in this case the combined approach here and the resulting GPA, you would see what you probably would imagine looking at this p-value. There's a relationship here. And for those of you less savvy with statistics, the greater the overlap, the stronger the relationship between the two variables in question. In this case, of course, the combined approach and that GPA. However, when you look at the relationship between SI alone and GPA, you find that the relationship isn't quite as strong. Now remember, both were statistically significant. One relationship is strong, one less so. You look at the relationship between tutoring and you find, actually, the relationship is almost non-existent. There's a little overlap there, but it's almost non-existent. But my p-value, I rejected the null. What's going on here? Well, you will have overlooked, if you were, God forbid, to find yourself in that scenario, likely means you will have overlooked the correlation or the effect size for your particular study. If you were to look at these effect sizes here for a moment, you would see that the effect is fairly large for the combined approach, and in contrast, not especially large for that tutoring approach. And that, in fact, is accounting for the relationships that you see here, and largely for the statistical significance that you see here for this particular value. What's driving all of this? what's driving all of this is sample size. So when those of you that have a background in research or statistics probably recall from your coursework, from your experience, all the time that your mentors and your teachers spent talking a great deal about bias, a great deal about how to minimize confounding variables, how to strengthen internal validity. And yet, the irony of all this is that the very statistical index that we use in the end to gauge the effectiveness of various interventions is in fact confounded. It's confounded by the sample size. So if one were to conduct a study, one could increase the likelihood of achieving statistical significance by simply increasing precision, i.e. sample size. So if there's an effect there, if there's any relationship, like you saw in that earlier example, you will find it so long as you keep adding participants to your study. And that's a secret that a lot of folks are aware of, not as many folks really overtly get into. So I'd like to share here a quote from one of the titans in methodology here, Gene Glass, who was the father of meta-analysis, for those of you that are familiar with that approach. Statistical significance is the least interesting thing about the results. You should describe the results in terms of measures of magnitude, not just does the treatment affect people, but how much does it affect them. And that is the crux of what I'm here to share with you. And that is that statistical significance does not provide any information about the level of treatment impact that your intervention has had. We don't have the time to really get into the conceptual basis for p-values, but suffice to say that the p-value falls short in terms of giving you information about the level of impact that a given independent variable or predictor has on the outcome variable. This quote, I think, is just one of those classics. I've seen this probably a number of times, but I just think it's one of those classics. This is Jacob Cohen, maybe the most influential statistician in the last 50 years, in reference to statistical significance here. Everyone knows that all this means is that the effect is not nil and nothing more. Yet, how often do we see such a result to be taken to mean, at least implicitly, that the effect is significant, that is important, large? If a result is highly significant, say p less than 0.001, the temptation to make this misinterpretation becomes all but irresistible. What he's essentially pointing to is the very concept I was sharing with you earlier. This idea that if something is highly significant, the inherent assumption, erroneously so, would be, oh, it's a large impact, it's a large effect. Not true, not true at all. So, the equation you see at the very top is one that I encountered in graduate school, and I thought, at the time, and still do when I look at it, it's a very simple equation, but yet it's actually quite profound in what it means and in what it's communicating to us. So when we're talking about significance, when we're talking about those p-values, we need to remember that that p-value is driven by two factors: sample size, which I alluded to earlier, and the piece I want to spend some time talking about today, and that is effect size. The two pieces go hand in hand. The p-value is a product of those two factors. So if your effect size is very large, and I'll come back to what that is in a moment, then you increase the likelihood of achieving significance, or if your sample size is very high, then that precision will go through the roof, thereby increasing the likelihood of you rejecting that hypothesis. So the first two bullets, I suppose, we already touched upon. Just briefly, I was very fascinated by this topic, and when I was in graduate school, I said to my advisor, wouldn't it be interesting to see how people even interpret p-values? It seems in many cases people just look for p-values less than 0.05, but when you really pose the question, what does this really mean? Explain it to me in a conceptual fashion. A lot of people stumble. And so I said to him, he's the stats teacher of stats teachers. I just love him. And he was responsible for teaching all the first year PhD students just a series of statistics courses that they were required to take. And so he agreed to let me qualitatively analyze open-ended responses to a question on his final exam. This is at the end of the spring term. This is that capstone class at the end of the first year. And students were posed that very question. What is a p-value? It was contextualized. It was a specific scenario that was portrayed to them. But essentially, they were asked to offer an explanation of what a p-value is. And so me and one other graduate student spent time coding those responses. And what we found, because of time constraints, I can't really get into it, but what we found is that 65% of the students did not accurately identify what a p-value was. These are not undergraduates. These are not even brand new PhD students. These are PhD students completing that first year series of statistics, and 65% of them could not offer a correct interpretation of what a p-value was. And that was shocking to me. It still is when I reflect on it. Another sort of truism that I've seen, I wish I could tell you the source, but I hear it and I read it. This idea that p-values really resonates. P-values measure effort and not truth. And I'd like to think, I think many of us would agree that that's why we're in this business. That's why we're in the science. Because we want to uncover some semblance of truth. And yet, because of the nature of how p-values are structured, in many cases they're not measuring that truth, but they're measuring how hard you work to build that sample size. That's what they're measuring. So very briefly, one set of equations for the effect size D. There are, just a quick aside, multiple measures of effect size. D, R, there's an odds ratio that hedges G. I won't get into it because of obvious time constraints. And these are the conventions that Jacob Cohen offered for D and for R, 0.2, 0.5, 0.8. I'm sure this is something that is somewhat familiar to those of you that have a background in statistics and research methods. So, having said that, I now want to begin to contextualize things. How does this relate to our college? How do we use this information, etc.? So the one thing I want to stress, I cannot stress this enough, is that many of the folks, the vast majority of the folks, and I'm sure Jim would say this is very much true of Chaffey College, and many folks that work in our area across the state or across the country would say this about their respective stakeholders. And that is that these are not technical audiences. When you're working with committees, when you're working in these governance structures to make decisions that positively impact student outcomes, you're largely dealing with staff and faculty that don't have an expertise in statistics or research methods. So the challenge for you is to be able to communicate findings in a way that resonates with those non-technical audiences. And so you do that with the effect size. And so in our case, what we do is we offer the effect size, we offer those conventions, and oftentimes we offer additional context that helps them make sense of what that effect size means. So for instance, if you were to uncover an effect size of 0.8, the t-value of 0.8, what does that mean? Well, one way to say it, one way to respond to that is to say it's large. But in fact, what that tells us, based upon Cohen's U3 statistic, is that 79%, let's go back to the example earlier with, say, tutoring. Let's say the combined approach, I think is more appropriate. 79% of the students that took part in the combined approach achieved a higher GPA than the average student that did not partake in any intervention. You offer an explanation like that to folks, and many folks, even those that have very little background in research, they'll get it. That's a big impact. That's a lot of students we're potentially talking about, especially if we can roll this out to a large number of students at our college. So very briefly, we're running short on time here, so I'll sort of quickly go through these examples. This is an example stemming from equity data. Equity and diversity are critical to California community colleges. In fact, we're required to look at different matters related to equity. What you're looking at here is success rates, which percentage of grades earned by students that were C or better. So when we're presenting this information, oftentimes, well, always, we offer that effect size. And in fact, if I were to forget to offer this information, I would be called out. Where we see this, where are the effect sizes, Gio? We want to get a sense for how large these differences are. And specifically in this context, what we're doing is trying to identify potential disparities that exist between ethnic groups. And so what we do is we identify the highest performing group, in this case the Asian group, and we identify differences between that group, the highest performing group, and the other groups in our analysis. And you can see here, the one group that really stands out is the African American group. And so our college takes that information and develops goals, objectives, and strategies to begin to at least try to ameliorate that situation at our college. long-term planning, institutional effectiveness partnership initiative. So another mandate here, and this is something that's imposed on all colleges, is to develop long-term goals for achievement. And very briefly, we're tasked with identifying long-term goals for success rates, the math remedial rate, and English remedial rates. Remedial rates, of course, referring to percentage of students that start at a remedial level and can complete corresponding transfer level class within that 3-year period. And so how this relates to effect size is simply that effect size, those of you that are familiar with it know that it's very much tied to standard deviations. So effect size reflects the number of standard deviations that differentiate, say, two means or two percentages. And so in our case, what we simply did is we looked at the variability across a 10-year period, the standard deviation, and we use that as a basis to generate our targets here. So the targets you see here are relatively conservative. This is something that went through this elaborate shared governance process. It wasn't just me meeting with the president and saying, here are our findings, what should we do? It was, let's have a discussion across all these various stakeholders to see what we can come up with and what we can decide upon as an institution. So what I want to stress, and I think I need to stop here, I think I get too excited. I tell you, I get too excited here. But the one thing I want to stress, and I'll stop, is that these analyses and these findings are not generated or shared in a vacuum. The emphasis always is on sharing these findings in the broadest sense possible, not just with the executive team, not just with administrators, but with a vast array of constituent groups at our campus that includes students as well, so that all of them have access to this information, all of them can interpret, have the opportunity to interpret, ask questions about what it means, and then offer input about what the institution can do with those results. So I have more. I think the slides themselves, I think if you want to sift through it, if you want to just ask me afterwards, I'm happy to walk you through the other pieces I have left for you. But with that, I will stop. Thank you.